Local Food Systems and Small Farms Extension Educator housed in Cook County, Unit 6. He joined Extension in 2015 to focus on urban agriculture production programming for a diverse group of stakeholders. Zach educates, conducts research, and provides technical assistance in small-scale intensive and urban ag food production systems in the Chicagoland region and beyond, primarily delivery through a variety of platforms and experiential training, including the Master Urban Farmer Training Program. He is currently conducting ongoing demonstration and applied research in urban agriculture production at a quarter-acre South Suburban Cook Urban Agriculture Demonstration and Research Site known as SOSUCO. His main digital presence includes the Urban Ag Connect vlog series, which you may be familiar with, which is curated on the Local Food Systems and Small Farms YouTube channel. Zach holds a Bachelor of Science degree in Agribusiness Management and Horticulture from Illinois State University and a Master of Science in Horticulture from the University of Illinois Urbana-Champaign. He has been involved in small-scale intensive farming for over 20 years as an apprentice, employee, manager, and owner. Most recently, from 2008 to 2015, he was the manager and director of the Sustainable Student Farm at the University of Illinois Urbana-Champaign, a working intensive vegetable farm laboratory located on the University Fruit Research Farm. He currently resides and owns a 20-acre farm in Kankakee County, where he is developing various small farm enterprises. So right now, I'll go ahead and turn the program over to Zach to discuss containerized production.
Awesome. Thank you so much, Sarah, for moderating today and that wonderful introduction. And thanks everyone for joining us. And it's great to be on this side of the Small Farm webinar series. You normally hear from me via my emails and the coordination of the series, but today I'm going to be presenting this topic around containerized production, options when quality native soil isn't an option. And this is of interest to me, and I think to a lot of people for a number of different reasons, as will become apparent as we move through the presentation. What I want to get out ahead of is to let everyone know that this is really going to be heavily focused from a food production perspective. I do understand that containerized production is very popular for ornamental plantings and systems, particularly at the homeowner scale. And I also want to recognize that this containerized production, it's going to be coming from the perspective of multiple scales. So this topic I wanted to branch out a little bit to apply to, home food producers, community food producers, as well as seeing the context for which containerized media-based production could be scaled up to farm enterprises. So I think you'll kind of get a little bit from multiple scales. And this topic actually is genuinely sourced from feedback from the winter webinar series. So, every time you guys fill out these evaluations and give us feedback about topics that you want to hear, this actually has been a topic that has come up in past feedback. So I wanted to address it to a certain degree. So we won't hit on all specific food production systems. This is going to be a very generalized discussion. So we won't really go too intensive necessarily into herb production or vegetable production, or maybe how even to grow fruit trees in containers. This is going to be kind of a very generalized, broad overview today. Okay, so the main objectives is just to we'll talk mainly about the sort of context of why containerized production is relevant. And we'll spend a lot of time on media because this kind of dovetails from the present webinar I did last year about the saturated media extract soil testing procedure or media testing procedure, which is another ongoing project that kind of overlaps with containerized media production. So that'll become relevant as we go along. So we'll heavily focus on the context of containers and media, and then we will talk a little bit about some of the other management factors, and then very briefly at the end discuss some napkin numbers. So this isn't going to be a deep dive into the economics of containerized production. It'll actually be a very base level look at just sort of a base level container cost example and media cost to kind of give you perspective to see like what this could potentially cost to scale up. There's many other numbers you'd have to input into that. Okay, so we've got a lot to cover. I'm going to move somewhat quickly through this, and And yeah, we'll go ahead and get started. So why grow in containers? I'm sure many of us have, at a variety of different scales, have tried growing food crops in containers. Um, and you may be thinking, why is he talking about this? So how is this relevant to me or my small farm or my community food production system? It's relevant because in a lot of cases, it might actually be the only space that you have to work with. And there's a few different contexts to that. This picture on the left is a picture that I took before moving to my current farm, Fangwater Farm, that I own with my partner. We lived in town for a number of years, and while those beautiful heirloom tomatoes you see on the table didn't come from those containers you see in the back, they did come from a larger container that we'll talk about in a little bit. But you can see in the background, my partner really loves to grow herbs and a lot of different edible plants in containers that you can see in the background. I'm sure this is a familiar picture for a lot of us on our patio or decks in our front or backyard. Here's a great picture I took while on a golf excursion with my brother at Cog Hill Country Club in Lamont, Illinois. And I thought this was a wonderful kind of example of using, a hard landscape for multiple purposes. So this was near their one of their maintenance sheds, and they likely built this sort of concrete container. But in some cases, you may have locations around a building or on a site that could be filled with imported soil or some of the medias that we're going to be talking about to actually grow in. So I think that in this case, they used the space that they had on hand and made it so it could be used for containerized style production. And also, where else are our furry little squirrel friends who love to dig in all of our pots and make a mess of our garden gonna hang out? If we don't have containers for them to dig in, I mean, what else are they gonna do? I kid. This is a fun example of something I think I found on Instagram or Pinterest of using pallets to kind of anchor and utilize vertical space for containers that we tried out. We stopped doing it, but it just kind of give you just different ways that you might be able to utilize containers in small spaces. The other reason why you might want to consider containerized production is because it actually works, and it works really well, and it works instantaneously. So we're going to talk about raised beds as a large form container. So some of you might not be thinking about raised beds as containers, but I consider them to be, the kind of pinnacle, the largest scale of containerized production. And I'm sure a lot of us on this call, a lot of my urban ag constituents and stakeholders, they are very familiar with this style of production. Raised beds, containerized raised bed production works. You're creating this instantly bountiful, instantly high quality soil profile to grow in. This picture on the left, these are both work related projects. The one on the left is from the Proviso Giving Garden in Maywood. We helped them actually build this hoop house that these raised beds are contained in. And they just so happen to have one slat of the raised bed removed. And I thought it made an interesting picture to show you this, wonderful, this is a compost-based growing media, the wonderful soil profile that they have to grow in instantaneously, okay? Whereas if you're working with a native soil that doesn't have a lot of great soil quality factors, it might take several years, if not decades, to develop a soil profile that looks like this. On the right, this is actually from Precious Blood Ministries Community Farm in Inglewood, in North Inglewood. South back of the yards. And I took this picture because this is proof positive that, dwarfed containerized fruit tree production is possible. I believe these are dwarfed cherry trees that they have in, a 3 by 24 foot raised bed that they've successfully been able to grow and fruit these small dwarf trees. So it really does work for a variety of crops and a variety of conditions. And in fact, both of these are on the picture on the left is on kind of a gravel fill site, and Precious Blood is actually located in their containerized raised beds on top of existing asphalt. So here are just some personal examples on the left. This is at my grandmother's home in Kankakee, and just instantly creating this wonderful raised bed condition. We'll see this raised bed on the left again, and we'll see this raised bed on the right. This is my partner's little herb kitchen garden in the front of our house at Fangwater Farm. So you can create these instantaneous productive landscapes, whether it's in these containerized raised bed systems or individualized potted containers, as we'll see. The other reason why you may be considering this, and this definitely applies to many of the urban farmers and urban growers that I work with, is that you actually don't have a quality native agricultural soil to work with to begin with. So in the urban centers, that's definitely true in a lot of cases, but this is also true in a lot of the suburbs. So in, suburban sort of neighborhood development, a lot of times a high quality native topsoil is often stripped away to make a more stable base for building some of those newer neighborhoods. So if you're a suburban grower, you may find that even though maybe like heavy metal and environmental contamination isn't preventing you from using the soil, you may just have a compacted sort of waste fill layer that your neighborhood was built on, and you no longer have a good native soil to grow in. So anthropogenic soils is actually the proper term. I have discussions all the time with my urban farmers about what is actually an urban soil. Is there a proper definition for an urban soil? And anthropogenic soils is generally in the soil science world what you kind of refer to. And what this means is just any soil that's sort of influenced, modified, or created by human activity. So it could have at one time been a native soil, but maybe it's either sealed under pavement or asphalt, or maybe, the topsoil was stripped away, or maybe building fill materials are, brought to a site and capped off to where you're capping off the native soil. So, and a lot of this just comes down to human disturbance or anthropogenic disturbance. So this is what we often find definitely in the urban core areas. But as we move out into the suburban and exurban areas, we can also find these anthropogenic soils as well. So some characteristics that we focus on with urban soils, that very last bullet is one that gets hyper attention and hyper focus in the media, as well as, within research communities, as well as within grower communities, is this concept of heavy metal or other environmental contamination, like, aromatic hydrocarbons and things like that. Now, this may be the largest concern, and we're actually conducting some research into heavy metal contamination in urban soils currently. And that may actually preclude you from using that soil. But even if you say do a proper analysis and site assessment of your soil, you may find that beyond heavy metal contamination, even if maybe there's not heavy metal contamination, there's a variety of other soil quality factors that we teach and talk about when we talk about soil quality management that may be present that would prevent you from using the soil in the first place. So, things like heavily compacted soils, restricted aeration, elevated pH in a lot of cases, and just things like that. So you might have a situation where maybe your soil isn't contaminated, but the quality of that soil is so poor that you may consider using containerized production because it's just an easier way to get started in a variety of contexts, from the very small homeowner scale, even up to sort of mid-level commercialized production in certain cases. So how do you know? So this question comes up, and we talk about this in our Master Urban Farmer Training Program, is how do I know if my soil is a native agricultural soil or it's this sort of anthropogenic soil you're talking about, Zach? Well, there's a few different things to consider, and we don't have time to go into all of these, but I just wanted to give you a few tools and few tricks to think about. And the first one is observation and the site location itself. So just what I advise a lot of people to do, the first thing I do when I go to a new site, or the first thing I did when I came to Fangwater, is I went out and I just started digging holes. So I found different areas where I potentially wanted to establish market gardens or bed production. And I just dug a bunch of holes to kind of, at least maybe about a foot, 6 inches to a foot down to begin with, to kind of see what's going on with the soil profile. Just to kind of get, and, maybe do some, sort of feel site-based assessments based on color, based on soil texture feel. There's different things you can do just going to a site and digging a hole, as I like to say. But there are also some other just like general observations you can make, like, is the lot paved over? Is it around a heavily developed area? Is there industrial sites nearby? So there are some things that you might want to observe and already instinctively know are there that might give you some hints that this might not be a quality native agricultural soil. You can also consider land adjacent to your site. So our urban ag demonstration site in South Cook County, you can see a picture of it here on Google Earth Pro, is in Matson. And while this is more of a suburban kind of para-urban characteristic, I actually went back and looked at historical, what they call sandborne fire maps, as well as other aerial imagery dating back to, the mid 1920s, to kind of get a feel for what was actually going on that site before Matson was pretty well developed. And this site actually was, a native agricultural soil. So on to using mapping tools. So there's a few tools that are out there. The USDA Web Soil Survey is one that some might be familiar with, and that's a great interactive tool that you can kind of play around with. I actually am a big fan, for those of you who have taken MUFTP or other trainings, of Google Earth Pro. So this is a free, downloadable for PC only. There isn't an iOS or Android app version of this, but you can download this software. And what it does is it takes your standard Google Map or Google Earth imagery, and you can overlay all these different tool functions into it. Okay, so what you're seeing here is just a screenshot of what it looks like. I actually have overlaid some GIS files on it that actually gives me that USDA Web Soil Survey data overlaid into Google Earth Pro. So when you see those numbers 146A and 232A, those are actually the two different soil types. They're two different, there's one a silty clay loam and a silt loam that are actually native ag soils at that site. So you could do this as a first level assessment, even in maybe an urban area, just to make sure that you don't actually have a native soil to begin with before you do some of this more comprehensive site assessment. So I'm sure some of you can't see this very well, and this was included in the PDF slide set. I will include this PDF in the email link afterwards. This is an urban ag growing media options decision tree flowchart that I developed for MUFTP. I'm not going to go over all this, but I think this is a good kind of stepwise fashion of thinking about your site that you have wherever you are, in an urban area, suburban, wherever, and kind of figuring out what growing system that you're going to actually implement. Okay, so we're not going to go through each one of these steps, but I think this is it's a useful kind of thought process to go through before you make any major decisions. So some of you might already know that you're going to grow in raised beds. Some of you might want to be focused on hydroponics or aquaponics. But I think before you make these big decisions about your production system, go through a stepwise process and think about these factors before making any costly decisions or purchases that you may not that you would regret, but that I think it's a useful thing to go through. This actually was a suggestion from one of our students who, when we talk about these different media growing systems, they thought it was so confusing that they wanted some sort of just basic sort of flow chart decision tree to help them kind of make their decision. Okay, so talked about why. Now let's talk a little bit about what, right? So what different types of containers are out there. And again, this isn't going to be an exhaustive list, but I wanted to go through just kind of a few different examples that I'm sure some of you are familiar with, but some options that you may not think of as containerized production that really are containers. So let's just talk about the basic one right now. So these are just basic plastic high density polycarbonate planters that I purchased, I think from Farm and Fleet or Lowe's or one of those major box stores. And I wanted to do this experiment at my former in-town house to see if I could do some cucurbit production in these sort of shallow containers. And you can see here in the bottom left-hand corner, I actually just purchased some off-the-shelf, custom media that's specifically for growing in raised beds or containers. So this is Miracle Grow, and there's another company below that. I'm not advocating for either of these. In fact, I'm going to talk about developing your own media here in a little bit. One note here, some of you who are familiar with containerized production and have looked into this are saying, hey, Zach, why are you putting gravel in the bottom of your containers? I heard that gravel in the bottom of containers actually doesn't help with drainage, and in fact can hold more water than necessary. I've read and looked at some of those same articles as well. And I decided to do it for a couple of reasons. One, these are pretty shallow containers that I was a little bit worried about potential tipping in high wind conditions. So I wanted something to weigh the containers down. And I actually didn't really have any issues with drainage, at least as far as I could tell. We use this for some sort of heirloom French melon production that we trellised vertically, and we had really great results with this as one example. We'll see a picture of this with our irrigation management system a little bit later. These are also two very popular container systems that are out there that are, at least the system on the right is a little bit more applicable to homeowners and patio growers. These bottom water containers, there's a lot of different brand names for it. The one on the right hand side, you can see there's insert on the top where the media and the plants go. And then there's that little gray tube that you see there in the bottom left-hand corner of those containers. That's where you actually fill it with water. And through capillary action and wicking, that water actually, bottom waters those plants. So this is a pretty common thing that you see, and is scalable to a certain degree, but it's probably pretty expensive beyond, homeowner scale. Now, the pots on the left-hand side, these are fabric pots. Some of you may know the brand name Smart Pots. There's actually a bunch of different brands out there that all use these sort of either synthetic or natural-based fabric materials to create these really lightweight pots. And I think these have been very popular recently, and I think are applicable to both homeowner scale as well as medium scale sort of intensive production with certain crops. And you'll see an example of what I'm talking about here in a little bit. Now, I think with containerized production, we could also take our lead and a lot of guidance from rooftop farming as well. So this is an Instagram page that I'm citing here, Cork Rooftop Farm, Cork, in Cork, England. And I really liked what they were doing here with containerized production. So, and with rooftop farming, some of you may know that the media that you use in rooftop farming is a very lightweight, custom sort of media blend, and you're not using native soil. You're typically not using compost only for rooftop farms. It's typically a blended mix that's more accustomed to potting soils or containerized production systems. But the cool thing about this farm that I really liked and wanted to show you is that they actually built a customized movable pallet sort of containerized raised bed system. So you can see here they built these, what I would assume are maybe like 4x4 foot raised bed systems that they can jack up with the pallet jack and move around for management purposes, light purposes, harvesting purposes. I thought that was a really kind of ingenious way to use a rooftop system or rooftop space and containerized production combined together. Here's another example. This is inside the greenhouse that you see where they're doing traditional bucket style production of tomatoes inside of that greenhouse. So bucket culture can take on a lot of forms in hydroponics. We're not going to, containerized production with hydroponics is kind of a whole separate topic. We're really mainly today talking about media-based containerized systems. And I know some of you are probably saying, well, there are media-based hydroponic systems. You'll see what I'm getting at here in a minute. The media in this mix is likely a potting, soil, compost-based media that they're actually growing in. And this is, starting to see how some of this containerized production could be scaled up slightly. Okay, so this is an example of, these are actually smart pots. These are 15-gallon smart pots. This is at a farm operation. They're actually a potting media production operation called Dirtcraft Organics. This is their Instagram handle. And I wanted to show you this because this is where at sort of the more somewhat medium to small commercial scale containerized production there's a lot of interest in this space. And I think you can already guess at some of you what these two crops are that we're looking at. On the left-hand side, this is a containerized ginger production. And on the right-hand side, yes, you are looking at cannabis sativa, but this is not medical or recreational cannabis. This is actually high quality, what they call CBD floral hemp. So this is technically hemp cannabis, not recreational cannabis, but they are still growing it for the flower. So the flower can be used in a lot of different markets, whether it's distilled into oils or the flower sold as itself for a variety of different purposes. And because both of these crops, ginger and hemp CBD floral cannabis, can bring a pretty high return depending on your markets, containerized production does make sense. And this is very popular not only with hemp production, but also medical and recreational cannabis growers often use this sort of form of containerized production for their systems as well. So this is, and I just want you to note both the containers, the container size, as well as the irrigation system that you see there. We'll come back to discussing some of this in a little bit, but I just wanted to give you a context for what some of this looks like. Here's Dirtcraft's handle still, and these are some of the businesses that they sell to. These are CBD hemp farmers as well, but these are in controlled environment conditions. But as you can see, they're growing in containerized raised beds using these customized media blends for the production of their soils. This is an interesting one that I found from Subtle Seed Farm that Dirtcraft Organics is actually referencing. And this is kind of an interesting sort of plug and play raised bed system where they are using those plastic pallets, but on top of it, they're using this sort of fabric PVC style quick connect raised bed system. And this would work well for greenhouses, as well as work well for lighter weight media like the rooftop media that we just discussed in a little bit. This probably wouldn't work well as a raised bed for a heavier soil-based mix, because that's a fabric material that you see there. And that might not hold up as well to the weight of some of those materials. Now, just to kind of close before we get to raised beds, is to talk about other creative containers. This I found from Instagram as well, using different types of gutters that you can buy at hardware stores, and filling it with these lightweight soilless medias to grow things like herbs and salad green crops, utilizing vertical space along a fence. Now, to me, raised beds are absolutely containers. They are big containers, right? We might not think of them as containers, but when I think about containerized production, I think about raised beds as well. Here are some cedar-based raised beds at our demonstration site at a variety of different sizes. Here is that raised bed at my grandmother's house that I referenced. Okay, so you can see I laid landscape fabric down. You know, this is about, I think this is a 2 by 10 inch material that I like to use. 2 by 6 is kind of the low end for height. Some people, the sky's the limit in terms of how high you build them, although it costs more to fill them unless you're using backfill material. And here's that bed filled. They come in all sorts of different shapes and sizes. So this is at the OK Opportunity Knox Farm in Maywood. They have kind of normal standard size, like 4 by 8 foot raised beds, but also build some of these smaller raised beds as well. And we'll see this slide in a little bit for irrigation management in a little bit. And here is a demonstration site we built in Dalton a few years back. I put this slide up not just for the containerized system, but I also want to make reference to non-containerized bed production, or what I like to call berm bed production. Some of you might know it as concrete berm or wood chip berm style production that's often used in urban agricultural systems. So those beds on the far right, it's the same custom compost soil media that we're going to talk about in a little bit. But rather than putting it in a raised bed, we just build it up with mounds and surround it with a wood chip mulch to prevent the media from moving away. This is at a youth farm of Windy City Harvest. This is at the farm on Ogden. And there's plenty of examples of this. I'm sure a lot of you on the call, some of our urban farmer stakeholders in Chicagoland, very familiar with this style of production. I call this the kind of big containerized raised bed system, where an entire site is kind of containerized. It's capped usually with some sort of geotextile material, wood chips, and then structured up around the edges. And then these medias are put inside. And in this case, you can see they, rather than it being individualized beds, they're creating sort of market style garden beds within that larger containerized bed system. So this is kind of the largest scale that you tend to see this on. And you'll get a feel for numbers at the very end. But this is possible to do this large scale containerized system even at the large scale. So really quickly, just a reference to other DIYs raised bed materials. We often talk about wood, tend to try to avoid older treated woods, although some of the copper treated woods, there's varying levels of research as to whether or not that is an issue. But the main thing is that you can get creative, but try to avoid contaminated material as much as you possibly can. So you don't want to find old railroad ties that are soaked in creosote and use those as a raised bed. Up to a certain limit, people ask about tires and other materials. Just be very cautious about what you use in terms of building your customized material. I was really interested in building these sort of landscape fabric beds a few years back. I was at an urban farm in Cleveland, and I saw that this picture on the right where they just literally put some wooden stakes in the ground, wrapped it with some landscape fabric, and put their growing media right into that. And I thought, wow, that's kind of a cool way to build a raised bed for relatively cheap. So I did a quick experiment for a 32, or at least a quick napkin experiment in terms of a 32 square foot raised bed. And you can see there that it is cheaper than untreated pine or a red cedar raised bed. Obviously, a structureless mounded raised bed would be the cheapest. It's very cheap, but it's not very strong, and it's a little bit awkward to work with. So this is one that I built in my old backyard, filling with this media that we'll talk about in a little bit. And I actually made this into a miniature tunnel for kind of year-round season extension production. And I really thought it was cool, and I had a lot of fun building it. But my partner, when she saw it, she said, you know what, I wish you would have just built it out of cedar because it looks so much better. So if looks aren't an issue, then you can get very creative. All right, we're going to spend a little bit of time talking about media. We're about at the halfway point, and I want to spend some time talking about media because this is probably the most important decision that you'll make when it comes to containerized production, regardless of the scale that you're focused on, okay? So, and the big point here is that these medias that we're using in containerized production, it's not soil. And in fact, I would avoid using mineral native soils, even if you say you have a high quality native soil. Native soils do not perform as well typically in containers as they do in their sort of natural state, okay? Now, in some cases, you can mix soil in, as you'll see, with other different sort of amendments to create these custom mixes, but mineral soil on its own doesn't make the best media for containerized production in most cases. So I just want to reference that. So that being the case, it isn't soil, it isn't native soil, but we do want to replicate the attributes of high quality soils as best we can. So when we talk about soil quality, we talk about the three the 3 legs of the stool, right? All 3 legs are required for that to be a high quality stool that you can sit on. If you've removed one leg, it's just not as high quality. So one leg that we're very familiar with, that is the major focus of conventional farming in some cases, is the chemical sphere. So we do want to have the correct pH. We do want something that is potentially mineralizing and cycling nutrients if possible, holding on to nutrients. And we'll talk about container size and the volume of media and how this relates to that in a little bit. We also want the physical attribute. So it has to hold water, right? It has to be stabilized, and there has to be good aeration of the mix as well. So that's something that we do also want to copy. And then we cannot forget, which is often overlooked, is the biological sphere of these media mixes. So we want something that has biological properties, microbial, bacterial, fungal properties, for a lot of different reasons. So it can be nutrient cycling, it can be potential disease suppression. And there's a lot of reasons why we want to have all 3 spheres together working. So when we choose a media or we custom make a media, we want to have these attributes in mind. So a little discussion about, before we get into custom media blending, about other types of mixes that might be used as well. So this is a slide I pulled directly from our urban farmer training course. And we spend a lot of time talking about this slide because there's a lot to it. So this is the context of can't use the native soil, we're going to bring in something else. So that, and these 3 buckets, the sand soil compost blend, pure compost, or these custom potting blends that we were talking about, are kind of the 3 buckets that I like to think about. There probably are some other ones, but in general, I think most of these custom media blends fit into that. So the sand soil compost, and this is an example of what you see on the right-hand picture. This is an example of what you see in many of the raised beds and burn beds at our site, and in the pictures of the landscape fabric bed that we just looked at. So this is commonly available at a lot of different landscape supply centers or garden centers, depending on where you're at. And I recommend trying to source it locally, because what you want to do is typically, even if you're building just one raised bed or a couple raised beds or mini containers, you want to order in bulk if possible. And this material often can only be ordered in bulk. Sometimes you can pick it up, but if you're getting more than, I would say, 2 to 3 yards, if that's how much you need in total volume, I recommend getting it delivered. So this is what 3 cubic yards of a sand soil compost media blend looks like. And I just had my local landscape company drop it off right in my driveway about 10 feet from the bed. So it was really easy to move it into the raised bed, or really easy to pot your containers up with it. So the thing about this type of mix that I recommend is that this isn't necessarily legally controlled by any quality standards at the local, state, or even federal level. So you want to ask questions about this mix. So you want to ask questions particularly about, what is the compost that you're using in this blend? Typically it's spent mushroom compost. And then also, where are you getting the soil from? Is this a high quality soil? Do you have any soil tests or any sort of final blended ingredient tests before I purchase, 3, 4, 10, 20, 50, 100 yards of this material? A lot of times these companies won't have that available to you. You can do some of this testing yourself. Extension is working on a project right now to kind of try to do some of this testing. It's a longer term project to get a third-party assessment of the quality of some of these mixes. So, but I recommend trialing a small amount first. Now there's the pure compost, and we're going to talk more about pure compost in a later slide, so I'm not going to spend too much time here, but it is possible to grow in pure compost, but there are a few things that we have to look out for, and we'll discuss later. And then what we're going to spend the next few slides talking about is the sort of peat, coir, other amendment media or custom potting soil mixes, okay? So there's a variety of combinations of this you can purchase or you can blend up yourself. It's often the basis for the rooftop media systems that we discussed earlier. And we're going to talk about management and testing of the media in a little bit. And I'm going to you're going to see this term multiple times because I did this last year for the webinar series and we're an ongoing project about saturated media extract testing for this custom type of media. So really quickly, yeah, buy in bulk if possible. Buying material on an individual retail bag basis is always going to be more expensive. If you're just growing in a couple containers or maybe one raised bed, that might make more sense. But if you're doing, you know, dozens and dozens of large containers or multiple raised beds, try to source this in bulk. You're going to save a ton, literally a ton of money sourcing it in bulk. All right, let's talk a little bit about making media. And again, this isn't going to be for everyone. I have a vested interest in this because I'm interested in developing a potential media business on the side in the future. And I'm doing some initial experimentation with this at the small scale. So if you don't have the space, time, or capacity to do this, I don't necessarily recommend you do this, but this is a way that you can customize containerized blends for your particular needs. Okay, so this is my setup in our pole barn at Fangwater, and I'm actually using this 3.5 cubic foot cement mixer that I purchased for a little under $200. Some of you may have cement mixers, and these work really well for small scale batches. Obviously, larger scale media potting companies use much larger batch mixes, but you could use this at the very small scale, and you'll see this in operation in a little bit. So for the next two slides, you'll see in the top right-hand corner the ideal mineral or native soil mixture where we want, 50% air and water space, 5% organic matter ideally, sometimes it's more, or sometimes it's less, and then this mineral particle fraction. So what I'm going to do is just kind of compare and contrast as we look at the major and secondary components for a media, how it kind of compares to what we're looking for in an ideal soil. All right, so we'll try to move through this somewhat quickly because we still got a lot to cover. Could spend a lot of time getting bogged down here. But the major components for most of these custom media mixes, whether you make it yourself or you buy it from a garden center, are peats, perlites, and then maybe compost in some cases. Some mixes contain compost, some don't. It really depends on what you're trying to achieve with your mix or the level of fertility that you need in that mix and how long you're going to have plants in those particular containers. Now, I don't want to get into too much of a discussion about peat moss because I know there's a lot of you out there probably saying, Zach, peat moss, I've heard it's a completely unsustainable horticultural material. Why are you not talking about coconut or coir fiber or hydrated wood fibers or some of these other alternative medias? And what I'll say to that is that there's a lot of conversation and discussion about the sustainability of peat in horticultural uses. What I would say is that in the long term, I am interested in some of these alternative replacements for peat like coir and hydrated wood fibers. But as it currently stands, peat moss is really kind of the easiest and cheapest material to get in bulk. In fact, I tried to source compressed coir fiber, coconut fiber bricks this year, and it was nearly impossible to find them at the quantity that I wanted to find. Obviously, there's a lot of logistical challenges going on with COVID right now. And getting coconut fiber is one of those things, and it's subject to those global supply chain concerns. So, but peat is really a large part of it. And what this replicates is both replacing part of the mineral particle fraction as well as the water holding capacity of the soil. So about 60% or so of the soil. And in this case, it compromises about 35 to 40% of the total mix. And then perlite, the air is this expanded volcanic rock material that it composes about a quarter of the mix and is responsible for primarily aeration, but also some of the cation exchange capacity replacement in the soil. Now, some growers, this is where it might diverge between compost less mixes and mixes that have compost. Compost might make up 36% of soil of certain mixes. In the case of my mixes for transplant production and container production, it does include compost for a variety of different reasons. Some people use soil in this case. So if you were to use some soil, you could replace that or substitute or mix that with compost in a certain degree. So you can see this is about 98% of the mix is composed of peat, compost, and perlite. I have lime here because if you're using peat and you're doing this from scratch, you need to adjust the peat moss because it is a very acidic media on its own, somewhere between 3.3 and 4.4 on the pH scale. It needs to be adjusted upward with different types of dolomitic lime or calcium-based lime to bring it into that ideal pH range. So that's why I included it on this slide. Now, some of the secondary components, and this is where you can start to get into the real customization of these mixes, makes up only about 1 to 2, sometimes 5% of these mixes. Includes, in this case, and this is what I'm doing in this case, the fertility fraction of the component, as well as some of the microbial and fungal additions that I like to include in my mixes. So in this case, I'm using combinations of things like blood meal, feather meal, alfalfa meal, so these animal or plant-based meals, kelp meal, fishbone meal, and then the microbials, chelators, and the micronutrient portions that are, in this case, I'm using these pelletized humic acid granules, as well as in the foreground, you can see a couple of things that are microbial additives that I add, whether that are things like endomycorrhiza stimulation, bacillus, bacterial strands. I also, in this case, added a little actinovate, which is another trichodermic bacterial strand that I'm using to potentially combat damping off issues in my mix. So this is typically a smaller portion, but makes up a lot of the fertility of these mixes. And most of these blended mixes can be used right away. But if you're using higher amounts of, like, say, blood meal or higher fertilizers that you're putting in here that might have high amounts of ammonium, you may need to wait a week or two to allow the mix to compost and stabilize. Especially if you're going to try to germinate seeds or anything in the mix. So that's something to think about and caution. Here's just a quick little time lapse of me making this mix together. One thing I do want to note is I'm actually using a 3M N95 respirator on my face. And that's because things like perlite dust, the fertilizer dust, meal-based dust, you don't want to breathe in those materials. It's actually recommended that you use an N100 respirator for this. In this case, I don't have an N100, so I'm using an N95. But in this case, you can just see how I'm just blending these materials together, putting them in the concrete mixer. When you see the concrete mixer at this stage, it's actually not blending quite yet. You actually have to tilt in this case, I put that towel that I strap over it to actually blend the materials together to get them to their final state. Okay, so really briefly, I want to talk about compost before we get into these last few things about management to try to close out. We may run over a couple minutes, so just stick around if you can. So there's a lot of interest in compost as a growing media. Some people call it compostponics or just compost-based media production. And this is especially of interest in urban farming when we're importing compost to grow in containers, burn beds, or large structurized containerized raised beds. Now, it can absolutely be used as a growing media, but there's a couple important compost quality factors that we need to pay attention to. And I want to draw your attention to two primarily to start with. One is the carbon to nitrogen ratio. And this is a slide from Dr. John Birnbaum at Michigan State University, a big advocate of compost production and use of compost. And this is a great matrix graph that he put together, thinking about compost uses at a variety of different scales, anywhere from just simple inoculation in the case of like compost tea on the far left-hand side, all the way up to using it as a pure growing media or 100% of the substrate volume that you're using in your container. Now, as you can see, that what the bubble represents is a range of carbon to nitrogen ratios. And this is the carbon to nitrogen ratio of the finished cured compost, okay, not of the feedstock materials that went into making the compost at start. So a completed compost that's used as 100% media, somewhere between 17 to 25 to 1 would be a better ratio to look for a finished compost if you're using it as 100% media. Now, you'll see in the next slide, what tends to happen is a lot of growers have more access to what I would call a lower C to N ratio composts that are primarily based on animal manures. And those can be used as a growing media, but it's typically better if they're blended either with soil or blended with higher carbon to nitrogen ratio compost. And you'll see what I'm talking about in a second. The other thing to look out for is the electrical conductivity level, or salt level, as we like to call it, soluble salt level. And that's not just sodium, okay? This is also things like potassium, calcium, and some of these other nutrient salts that are in the mix. If you have a compost that has a very high soluble salt level, that would be better blended than used as a pure substrate, okay? And we're going to talk about the difference between traditional soil testing and saturated media extract testing in a second. And this is really important for these custom media and pure compost, as you'll see in a minute. So the other way, I just referenced this, I like to put compost into two categories, and it's not always the case, but high nitrogen compost versus low nitrogen compost. And the low nitrogen compost tend to be those ones that have the slightly higher carbon to nitrogen ratio as a finished product that would work better as an initial media, or to build soil structure, or if you're going to add large amounts, if you're trying to increase organic matter in your soil. If you're using a compost that's based on animal manures, then this is typically better for like a fertilizer boost and used as an inoculant, rather than trying to grow purely in a high nitrogen compost. So if you maybe wanted to blend both styles of compost, that would be better. I've seen some recommendations anywhere from 3 to 4 low nitrogen to 1 part high nitrogen compost as a kind of a finished blend for an ideal growing mix. So there's a lot of, customization within that you can experiment with. Now on to soil tests. So with these medias that we're talking about, or grown in pure compost, the standard soil test that you might use, so I use this lab, Midwest Labs. There's plenty of labs, not advocating for them as a vendor, but this is just an example of one that I use. When you test these compost-based medias or potting soil mixes that we're talking about, you tend to get results from a typical soil test back that aren't super useful. And what I mean by that is, as you can see the results here, the numbers are through the roof. And the reason why that is because traditional soil testing is actually a little bit better of an indicator of what to expect from a soil over a longer term period of time. Meaning that they actually use sometimes weak and medium acids as an extract solution when they test the soil. So when they introduce that acid to the soil sample, they're extracting everything that can be extracted from that soil and give you an idea of what you can expect in terms of yield over a longer term period of time. So in the case here, you can see this is the 2 samples at the top here that say Sosuko. Those are traditional, those are the native soil at this site. And the bottom 2 samples that say Berm or Easy Tree, those are a compost soil custom blend that I bought from that particular company. And you can see with the Easy Tree blend, all the numbers are just through the roof, very high for all the cations. With the exception of, if you look at the soil nitrate test I did, the soil nitrate levels are actually relatively low in that compost. And that's because that compost is a low nitrogen compost. And I expected to see that. So this is kind of useful information to give you a baseline to see maybe what your pH levels are and where your cations are. But a more useful test is the saturated greenhouse media extract test for these types of mixes. And this is a test that gives you a better idea of what to expect from a media or potentially a soil in a shorter to medium term, which might be relevant at the beginning and middle part of the season. And an SME test actually just uses distilled water for the extraction rather than a weak acid. And I actually have some equipment. We're running a test version of this with a few urban farmers in Cook County to potentially offer this as a service for our urban ag growers. And I have some colorimetry and selective ion electrodes to do this analysis. But you can see here, the Sosuko soils here, the pH levels from the previous slide. So these are the same, these bottom 2 Easy Tree samples. It's the same thing here, Sosuko Berm 1. Actually, Sosuko Berm 1, not the native soil. You can see the pH levels are pretty similar. The nitrate levels are pretty similar to that standard soil test, but you see the potassium level is super low. So this is useful information because even though that soil test told me that that compost-based media had a ton of potassium in it, in the short term, when I do the SME test, what I'm seeing is that there's actually very little potassium available immediately. So I may need to supplement a water-soluble fertilizer. It may have been the time of year that I tested it that's indicating that, but both of the tests combined give you more information than one test alone, particularly for these compost or customized media blends. We don't have a lot of time to talk about that, so I'm going to move on beyond that because we're getting low on time here. So a couple other things to consider with container management are other environmental factors like light, temperature, wind, heat absorption at the site. So you can think if you're putting containers on blacktop or concrete that there might be more heat retention and therefore your soils might warm up quicker. So there's other factors that you might want to consider. The other thing to think about with all containerized production, whether it's raised beds or single pots, is they dry out much quicker than your standard soil. So irrigation is super important, and we're going to talk about that next. Container size is also important. This is actually a slide that relates to transplant production, but in general, and I think this applies for container media-based production, the larger, if you have a longer term crop that you're trying to grow in, the larger the container, the more media that you have in that container, will create better results for you. So it's definitely true with transplant production. You can see a 4-inch tomato transplant on the left-hand side versus a 2-inch container. You can see the stark contrast and differences. Those tomatoes were started at the same exact time, just given more root volume to grow in, that you get better results with the larger container size. Now, container size is often, that's a question that comes up, is like, what size should I use for different types of plants I'm growing? There is data out there, like charts like this, that show you which container size to use, but I recommend experimenting depending on the results you get and how long those crops are actually going to be in those containers. So even if you blend up a custom fertility blend, you do a saturated media test, you do a standard soil test, and you think you have your fertility dialed in, it never hurts to have some fertility that you can inject into your irrigation system or hand water at any given time. This is that easy tree mix that you see here at our Sosuco site. The tomatoes in the background are doing fine. Part of this might be there's too much material, plant material in this container, but you can see there's, with those pepper plants in the foreground, there's definitely some nitrogen deficiency going on, and I should have supplemented that before it became too much of a problem. That's a fertilizer injector that you see there on the right-hand side. And if you're building out these irrigation systems for your containerized production systems, you can inject fertility directly into a drip or an overhead sprinkler system, so you don't have to, hand water individual containers. And we'll see what those systems look like in a second. So I think, again, irrigation management with containers is a super, probably the most important management factor to consider, because these materials tend to dry out quicker. You need to make sure that you have a reliable amount of water to them. So I like to use, in addition to hand watering, which I'm not going to reference here, drip and overhead, depending on the situation. So here on the left-hand side, you see a drip system set up. One thing I would notice is that I'm actually extending the distribution tube across 2 raised beds, and it's creating a tripping hazard. What I would recommend doing is what you see here on the right-hand picture. If you can bury your distribution lines to get the water to the raised bed, that would be better. Of course, if this isn't below the frost line, you'll have to blow that water out each year if you want to keep it permanent, but that prevents tripping hazard and makes your site look much neater to get that water distributed to your beds, and then you can distribute it via drip that you see here, or overhead that you'll see in a minute. So the containerized melon production I was referencing earlier in that top left-hand picture, I use just your standard drip tape in that system. So I just literally laid a drip tape over the top of the containers down the full length of that bed system, and it worked great. Now, there are some systems out there that like to use this 1/4-inch sort of coiled drip tubing for individual containers. This is some schematics I pulled from DripWorks, which is a really cool drip irrigation supply company. That their kits tend to be pretty expensive, but you can get some of these individual components cheaper. But the thing I like about companies like this is that they put these plans together for you to visualize your irrigation system ahead of time, and then they've done all the shopping and punch listing for you, and you just have to order the particular equipment. They even give you information here about the flow rate requirements and things like that. Okay, so I really am interested in these individualized dripped coil 1/4-inch tubing systems that I think would work really well for your fabric pot or smart pot systems. So here's a micro sprinkler scenario, and this is something that I have for my raised bed at my home. And I like micro sprinklers for things that I'm direct seeding. So anything that's a shorter crop that you're direct seeding that you need to get to germinate quickly, micro sprinkler systems work really well. If you have longer season crops like tomatoes and things like that, the drip irrigation systems work a little bit better. So here's another version of micro sprinklers that you see here in one of my low tunnel systems. And again, this is just from DripWorks. I'm not, again, advocating for them as a vendor, but I think this is a really cool example when companies put together these 2-scale diagrams of what your maybe containerized system would look like and all the different components that you can order. I would also recommend doing this yourself and sort of drawing out all of your irrigation component system needs ahead of time yourself if you want to, and then you could order these components individually. Okay, the last 2 slides, and we're running right up to the hour, but we will stick around to answer some of these questions. And again, these numbers aren't all the economic considerations, especially for commercialized production, but these are just some generalized napkin numbers to kind of consider if you're thinking about containerized production. So in general, and this is very in general, and this can range depending on your materials, if you're interested in a raised bed style large containerized production system, examples that we saw earlier, your average cost just to build out the beds to begin growing in, so this could include the structure, if it's structured, and the media, is somewhere around $1 to $2 per square foot. Okay, that's very general. It could be a little bit cheaper, it could be a little bit more, but that's a general ballpark number I like for you to think about if you're going to do it this way. So materials only, no labor, reasonably priced bulk media. If you wanted to do 1,000 square feet of production, you're looking at $1 to $2 grand just to get that system set up before you begin growing. So you can see why that flow chart that I put together initially is important, because if you do have a high quality native soil you can grow in, economically it might make more sense for you to use that high quality soil. But because you're going to spend, you know, $1 to $2 per square foot just to start growing. Whereas if you have a soil to grow in, you could use that capital for other equipment purchases to start out. Now, if you were interested in like the fabric pot system that you saw for the ginger or hemp production, here's just some basic idea of what that might cost just for the container and media. So this is based on an experiment we're actually going to be doing with hemp in our high tunnel this year that I've crunched the numbers. It would cost about $5.50 to $7 per square foot to utilize a fabric pot system with a customized media to fill each container. So you can get just a general idea of the range of numbers and how much it might cost to get started in this space. Okay, to summarize, containerized production, totally possible for a lot of scenarios. It's definitely going to be more expensive to start than your high quality native egg soils. If you're going to use imported media that you're not making yourself, try to get it tested if possible, or ask the vendor if they have test results. Bulk material purchase is always cheaper than retail pricing for like single container builds. And containerized production requires more attention to moisture and fertility control in terms of management. All right, we'll go ahead and end there. Here is the evaluation QR code. You'll see the link to the hyperlink version in the chat box. And we're right up to the hour. I know that, but let's stick around and answer some of these questions for those of you who can stick around. If you can't stick around, these questions will be recorded and you can check it out when I send the link out. So thanks everyone. And yeah, let's take some questions here. Awesome.
Awesome. Thank you for that great presentation, Zach. We do have a few questions for you. Earlier on in the presentation, we had a few questions that came up around raising trees on asphalt. Do you need anything special in the winter? And also, do you need a barrier between the soil and asphalt?
Yes, I see Holly and Chris. Thank you for those questions. Those are great questions. And I knew when I put that slide in there that I was going to get some tree questions and containers. So I actually don't have personal experience with it, but based on what you're saying, like I think I have some maybe general recommendations. So in general, yes, those containers that you saw at Precious Blood, they did actually have a barrier between the asphalt and the new media that they're growing in. Okay, so that is one thing for sure that you could consider in terms of, you know, the roots growing through that and possibly trying to penetrate and interact with the asphalt or the native soil. You know, that may happen over time, especially if you have like a perennial crop, like a fruit tree in a containerized bed. The one thing to note though is that there is good research that shows that if you do have contaminants like heavy metals in soils, there's very little, if any at all, uptake of that metal that makes it into the fruiting part of a crop. So that is one consideration to think about. But in terms of winter protection, that's a good point. You know, those beds actually probably do freeze a little bit quicker than a native soil would. I don't know if you need additional protection. I think it all depends on the hardiness of the dwarf fruit tree species that you choose to put in that container. So that's a good question. I don't have a solid answer for, but it would be something to consider. In terms of the depth that Chris is asking about the dwarf trees, I don't know. Those beds are about 3 feet in depth and about 3 feet wide. So I think for dwarf fruiting tree species that are dwarf grafted onto dwarf rootstock, that would be a sufficient volume. So you have to be very careful about your variety selection.
All right. Nick had a question on, have you seen any growth or yield issues with deeper rooted crops like carrot, beet, enlarged raised beds like the one at the farm in Ogden?
Yeah, I'm reading the comment now. I think the costs are a hard time, especially asphalt ground. So yeah, I personally don't have any sort of negative experience with it. I think it all comes down to the volume of custom mix that you put in a container and potentially the overall depth. So in the case of something like taproots or carrots, yes, you would definitely want a container that has a little bit more depth so they can, you know, fully root out and form that full taproot. And I think your limitations in terms of yield depends entirely upon the custom mix that you're putting in that container. So if it doesn't have enough fertility to get it to the end of its life cycle or harvestable life stage, then that's something that you have to tweak in the mix to start with, or you'd have to, you know, amend with additional fertility as you're going through that. So it's a good question. And it is something to consider. Yeah, I'm not sure in terms of, especially on asphalt, hard permeable ground. Yeah, really all of those containerized systems, whether they're structured or non-structured, you have to attain a certain depth. And for some crops, you know, 3 to 6 inches might work, but for most crops, I think getting in that 12 inch to 2 feet range is more ideal. Oops.
All right, there was a comment from NJ on growing trees in containers at Millennium Park. So that's just something for reference for our viewers if they want to look into. Our next question goes from Cindy. How many growing seasons are you expecting from unfinished pine beds to last?
Oh, that's a question that comes up all the time in terms of the, you know, treated versus pine versus cedar. You know, I've gotten 5 to 6 years out of cedar beds in the past before they get, you know, too rotted or they have to replace. A lot of my experience with pine comes from kickboards on high tunnels that are in contact with the ground, and those tend to you have to be replaced every few years or so. So it really depends. I still haven't found a good sort of natural wood treatment that can be utilized. I've heard people recommend linseed oil, but I think it depends on the source. Some people recommend lining it with plastic or putting additional furring strips on the bottom of a bed to allow those to rot first before the bed actually starts rotting. So it depends on a number of different factors, which is a reason why you have to pay close attention to the numbers with containerized raised beds because you spend a lot of money on it and they're only going to last for a certain amount of time. So it's a good question. I don't have a solid answer, but somewhere in that 5 to 6 year range is what I hope to get out of cedar beds. Pine beds, a few years less than that.
Awesome. Quick question here from Laura. Are cinder blocks safe for growing?
That's a good question. I have cinder blocks at our site that I was wanting to experiment with as a raised bed growing media, or a system or container, I should say. And in general, I've gone down some rabbit holes with that. I've seen people say in general, yes, they are safe. I have also seen that some cement products that are used to make concrete cinder blocks, that they may have certain levels of heavy metals that might be concerning, but I don't have a lot of solid data to back that up to say definitively don't use it. I think if you have cinder blocks that are breaking down, falling apart, and that mixture is working its way in the soil, that might be more of a concern. But I mean, in general, I've seen a lot of people using cinder blocks for raised beds. It's a great question, but I don't have a solid answer for you. So, but I've seen arguments both ways.
There was a positive comment from Gwen about loving the hoops on your raised beds. What do you use to bend them in that shape?
Oh, thanks, Gwen. Yeah, a lot of you who know me, I'm a big fan of these mini tunnel hoop systems. We've done a couple in-person workshops to show you how to bend them in the past. We'll be doing more of those once we can meet in person again at our demo site. And those hoops I actually just used, those are 1/2 inch electrical metal tubes, and I just used a 1/2 inch bender that you can buy at the hardware store to do that. I have some materials I can send to you, giving you a schematic of exactly how you bend it. There are also benders you can buy from companies that can bend, half circle shapes, in a variety of different shapes to make those small tunnel hoops. But in that case, I just use the EMT bender.
Okay, that kind of answers that next question somewhat about purchasing the low, where you purchase the low bed hoops. From Judy, what is the best way to amend soil for containerized blueberry bushes?
Well, blueberries are one of those hot topics right now. I've gotten a few questions from some friends about putting blueberries in. We actually put in some blueberries at Fangwater, and our soil here levels, it's pretty high. It's somewhere between 7 and 7.5. And as we all know, blueberries love acidic soils in that 4.5 to 5.5 pH range. So I would think that containerized blueberries would actually benefit from a peat-based media where you're very careful about how much lime you add to the peat. So in the case of pure peat moss, it's somewhere in the 3.3 to 4.4 range. So if you just added enough lime to bring the pH of the peat-based media up to 4.5 to 5.5, that you would probably have really good success with blueberries in a large enough container. So that's a great question, Judy, and actually maybe inspire me to try some blueberry container production if the ones I have here in my soil don't take. So really great question. And I see Eric's comment here next about vendors for bulk material purchase. Absolutely, Eric. We have a kind of a working list right now, and I'm sure some of the vendors you're familiar with in Chicagoland. But yeah, one thing we do want to do is try to get some third-party testing verification of some of these mixtures, because our experience is that some of the vendors have the certification, but some don't. And they'll give it to you if you ask them for it, but it would be nice to get some independent verification for some of these materials and learn more about the feedstock materials we're using to make some of those blends. I think there was one question earlier that I missed from Chris about containers on top of pallets on a cement driveway, but still had 2 warm root zones, less production, wrapped them in white plastic. So that I briefly kind of flew through that part in the management section, but I think that's a great point that he's bringing up, is that we have to think about these containers sitting on these exposed asphalt or concrete patios or surfaces where we would have excessive drying or excessive heat buildup. And it would be something to consider. So his idea of wrapping in white plastic or maybe some sort of aluminum reflective material to reflect some of that heat away, especially in the middle of the summer. That's an interesting concept. I also like the idea of the movability of containers, because you could maybe move them to different sites where there's certain microclimates that might favor them at different times of year. So that was a great question that got brought up, or point.
Great.
Awesome.
Well, I think that wraps up our questions and comments for this afternoon. So I'd just like to thank you, Zach, once again for this great presentation and sharing your insights on containerized production. I'd also like to thank everyone for joining us for this webinar. I hope you got some information that will help you on your small farm endeavors, and hopefully even something you can put into place yet this year. So please look for an email from Zach with a link to the archived webinar on the Illinois Local Foods YouTube channel, as well as a very short evaluation of the webinar that you just watched that is also in the chat box. And we do look to you and are reading that feedback that you provide as it shapes our future webinars like today's presentation. So with that, have a great day, and we hope to see you again next week.
Awesome.